Recording in progress.
Okay, so we started our discussion on group 8 elements. What is the special thing about them? What we were discussing? Why group 8 elements are known
Um,
as noble gases? This is a very important question and a very important concept.
because all of their what's it called
Valence
valence
shell
shell are like full.
are filled,
Yeah.
yes. Only
Yep.
helium follows the duplet rule, right? It has
Yeah.
two electrons in its valence shell like this. All other elements of the group 8, they all follow the octet rule,
Octave.
right?
Yeah.
So their valence shell is filled. That's why we say that group
Yeah.
8 is a special group. It does not need to make bond with any other element. Okay, it does not react with any other element. Why it does not react with the element of other group? Because they are full. They don't need any electrons. They don't need to be the sharing of the electrons, or they don't need to gain electron from any other group. Okay, that's why we say
Yeah.
that they are noble gases. They all are
Mhm.
gases. Remember this thing. Second, their octet is full, octet or duplet. Not octet, we can simply say that their valence shell is full. Okay, it is filled with
Yeah.
the electrons, it is full. And the third thing is they don't react. They do not
Yeah.
react. That's why they are noble gases.
Yeah.
Okay,
Yeah.
yeah, that's why they are unreactive. They do not react because their atoms have a full outer shell. Okay.
Outer shell. Yeah.
Now they have discussed calcium is the 20th element in the periodic table. After calcium, the electron shall fill in a more complex order. As we will discuss this, like they have mentioned about this configuration. Like for the rubidium, they are telling us that rubidium is the 37th element, right? Its proton number is 37. So how it will be filled? Firstly 2, then 8. How many are these? 10, right?
10. Yeah.
Then 18, then
Yeah. 18. And then 8.
8, yes, and then 1. So this is what they have mentioned that this after 20th element, the electronic configuration become complex. Okay, but our
Mm-hmm.
concern is still this. We will discuss it. Okay. Now these are the questions. One element has atom with 13 electrons. Draw a diagram to show how its electrons are arranged. Give its electron. I gave you this exercise. Did you solve it?
Yeah, I sent it to you.
You okay? Send me this. You didn't send me. I gave you this homework last in the last class. Okay, send me after the class. We will discuss it in tomorrow's class. Okay.
Okay, I'll send you this.
Okay. Now we are going to discuss about the isotopes and the how to calculate the relative atomic mass. AR means the relative atomic mass. Okay.
Mhm.
Firstly, what do you know about isotopes?
Isotopes like
Mhm.
how the I'm not sure, but like something that like
Mhm.
has the exact numbers as
Mhm.
like different electrons and protons.
Uh, Not electrons and protons. We simply say there are different number of neutrons.
Neutrons,
Yeah,
neutrons.
because electron.
Yeah,
We have discussed
protons.
that electron and protons are always same, right? In a neutral species,
Yes.
electron and protons are always same in number, but the neutron number is
Yeah.
different. Okay, and due to this neutron number, we say that mass number is different. Okay, isotopes are those in which atomic number is same. Okay,
Mm-hmm. Yeah.
but mass number is different, right? How mass number is different? It depends on the number of neutrons. Okay, neutrons are
Neutrons. Yeah.
different. That's why the mass number will be different. Okay, that's why we say the isotopes are the atoms of the element which have same atomic number but different mass. Like this, for example, if you see
Yes.
this, these three are the isotopes of carbon, right? This is carbon 6, 12. It means how many electrons are there? 6. Protons are also 6, and neutrons are also 6.
Yeah.
But if we check the carbon number 13 in this, protons and electrons are same, just like this, 6 protons, 6 electrons. But now there is an addition of 1 neutron, right? So there are now 7
Yeah.
neutrons In this carbon 14, there
Yes.
are 8 neutrons. So this is known as carbon 14. Okay, this is carbon 14.
14.
This is carbon 13. And this is carbon 12. Okay, I have a question. All
Mhm.
these three uh, atoms of the carbon are available. Okay, all these three isotopes are present in the Earth's crust. But why we always talk about carbon 12? Like you see in the periodic table,
Or
there is
because like
carbon
it's
12.
the most like maybe it's like the most common to find. It's like in the air.
You are right. It is more abundant. Okay, it is more abundant
Mhm.
and it is
Yeah.
present in more amount as compared to the other isotopes. Okay, this is the reason we have
Mhm.
isotopes of different elements, right? It's not the case that we just have
Yes.
isotope for carbon, we have isotope for neon, for all other atoms, but we always mention those which are in the periodic table. We always mention those which are abundant in nature. Okay, those we can easily find that we place in the periodic table. Okay, we don't place all the isotopes.
Mhm.
Okay.
Yeah.
Okay. Uh, so the three atoms above are the isotopes of the carbon. Isotopes are atoms of the same element. Okay, same element. They have same number of protons but different number of neutrons. Okay, same number of protons means their
Neutrons.
electron number will also be same, right? In the neutral
Yeah.
species, in the
Yes.
neutral atom, we discussed that electrons and protons are same in number.
Same.
Yes.
Yeah.
Most elements have isotopes that occur naturally. For example, oxygen has three. Yeah, oxygen has three isotopes. Iron has four. You must know these. Iron
Yeah.
has four. Magnesium has three, as well as chlorine has two. We will discuss those and those which are present, which are mentioned in your book. You must know at least those. Just like the carbon, that
Yeah.
there is carbon 12, carbon 13, carbon 14. Okay. In all these, if I ask you in the question, what is the common thing in carbon 12, carbon 13, and carbon 14? What will be your answer?
Like what's it called?
Mhm.
Like most common in there.
What is the common thing in all of these? In all of these three isotopes, carbon 12, 13, and 14.
Like they have the same like
Hmm.
what's it called? They have
Yeah,
the
same number of.
isotopes.
No, these are
Like
isotopes. How? These are three isotopes. What is the common thing in
yeah,
these three isotopes? Same
the
number of
similar neutrons
protons.
and protons.
Yeah, same number of protons and same number of
Neutrons.
electrons, not neutrons. Neutrons are different,
Electrons.
right? That's why we
Mhm.
are saying them isotopes. You know,
Yeah.
iso is from the, it is a terminology that translate into the meaning same. Okay, same isotopes,
Yeah.
same atomic number. Remember this thing,
Yes.
isotopes, all the isotopes, whatever isotope we are
Mhm.
discussing, in it, only neutron number will be different. Okay, neutron number will be different.
Mhm.
And
Neutron
when
number.
neutron number is different, you know what happens is that the mass number differs, right? Mass
Yeah.
number differs. Atomic number does not differ. Why atomic number will not differ?
Because it's same as
Mhm.
like proton
Because
plus
how?
neutron.
No.
Proton plus
What is
electron.
atomic number?
Oh.
What is atomic number?
Atomic number
Mhm.
is what's it called? Atomic number is like the protons and like found
Mhm.
in the nucleus.
Protons.
Yeah.
So this is what I'm saying. Like
Yeah.
you have protons, right? And
Yeah.
so that's why the since as you know the protons are same. That's why what we will say that the what is same? Proton number is same. It means
Like
hmm.
yeah, that means electrons are same as well.
Yes. That means electrons are also same, and that means your atomic number is same. Okay. Let me explain it again.
Yeah.
What I'm saying is that, for example, we are discussing about the isotopes. Firstly, tell me what is atomic number.
Atomic number is the number of protons.
Okay, atomic number is number of protons. What is mass number?
Mass number is protons plus neutrons
Number of protons
and neutrons.
plus neutrons. Okay. If I'm saying that in any species, like for example, we have carbon 6, 12, carbon 6, 13, carbon 6, 14. If I'm saying in all these isotopes of the carbon, the number of protons are same, then what I'm saying, what is same? Number of protons same, it means atomic number is same or mass number is same. What will be same? Check from there.
Atomic, what's called mass number.
No, number of protons are same.
Yeah,
So what will be same? Atomic number or mass number?
atomic number.
Yeah. So that's why we
Atomic
say
number.
that since in all the isotopes, since in all the isotopes,
Hmm.
number of protons are same, that's why their atomic number is same. Okay.
Atomic number.
Okay. Now, what will be different? What is different in this? What about the what is your perspective about the electrons number?
It's the same as protons.
Yes. In a neutral species, in neutral atom, just like these are neutral, you know, there are no charges on these. So in
Yeah,
a neutral atom, number of protons is always equal to the number of electrons, right?
yeah,
So that is why in all of these, electron number is also same. Now, what we are
yeah.
discussing, if you see this, what is different? 12, 13, 14, what is different? What is this?
The
12, 13, 14. What we
atomic
say?
number.
This is not atomic
Atomic.
number. Atomic number is this.
No,
This
I
one
mean
is
the
atomic
mass
number.
number. Sorry.
Yeah,
The
that
other
is
one is
mass number.
atomic number.
Yeah, that is mass
Yeah,
number. Okay, this is mass
yeah.
number. So what will be different?
Oh, the mass number will be different.
Yeah, mass number will be different. So, and why mass number will be different? You see 12, 13, 14. Protons are
Yeah,
same. Why mass number will be different? Because number of neutrons are different, right? If you
yeah,
if you check
yeah,
this one, the first one, let's talk about this one. There are six protons, right? In this six protons.
yeah.
How many electrons are there?
Six.
Okay. How many neutrons are there
Or
in this?
neutrons. Uh, and this 14. Oh, it's six.
Six. Six neutrons. What about this one?
Yeah. This one has six protons, six neutrons, and seven neutrons.
Six protons.
Six protons, six electrons, and seven neutrons.
Yes. What about this one?
It has six protons, six electrons, and no,
Hmm.
seven
Eight.
neutrons. Eight.
Eight neutrons.
Oh yeah,
Okay. You
eight,
see?
yeah.
You
Yes.
see what is different? Neutron number is different. So
Yeah.
since in all these, what is different? Neutron number is different.
Neutron.
The number
Yeah.
of neutrons in all three isotopes are different. That's why what will be different? Atomic number or mass number?
What's it called? Atomic. No, mass.
Yeah, that's why mass number will be different. Okay.
Yeah.
Okay. They can also mention like this. For example, I am writing it like this. Carbon 6, 12. They can mention like this. Its atomic number is 6. Atomic mass is
Mm-hmm.
okay. So this is how they can give you. So you must know if they mention like this, so you must know what is common, the number of protons and number of electrons.
Yeah.
Okay. Okay. Now one more thing that
Yes.
is a very important concept which I am now going to tell you is about. They have mentioned that number of protons will be same and number of electrons will be same, right?
Yeah.
Since number of electrons will be same, so what can be okay? Yeah. Since what I'm saying is that electrons are same, right? Electron number is same, so it
Yeah.
means the number of electrons in the outermost shell will also be same, right? In all these three.
Yeah.
Are you getting this? Like for
Yeah.
example, we are
Yeah.
saying that there are 6 electrons in this, there are 6 electrons in this, there are 6 electrons in this. What will be the electronic configuration?
Yeah.
2. What will be electronic configuration?
2 is 4.
2 and 4, right? It will also be 2
Yeah.
and 4.
4.
2, 4.
2 and
So
4.
it means this is the valence shell, right? This one. So how many electrons are in
Yeah.
this valence shell?
4.
4 electrons. So this is what I'm saying, that if we are talking about this, that in this we are saying that the number of electrons are same, since number of electrons are same, it means that number of electrons in valence shell will also be same, right? Are you getting this? We are saying total electrons are same, like 6 electrons in all these three. So the number of electrons in the valence shell will also be same. Are you there?
Yeah.
Okay. Okay. And then, yeah, what I was saying. Yes, the number of electrons in the valence shell are same, right? So what does it tell us? It tells
Yeah.
us about the what information we get from the valence shell electron. You know what? There are 4 electrons. So what information we get from this? The valence shell electron. Always remember this thing,
Uh,
that the valence shell electrons,
it's always same
yeah,
for
they are
this.
same. But these
So,
electrons, they tell us about the bonding pattern, right? Just like I
yeah.
told you, if there are 6 electrons in the valence shell, so it means
Yeah.
that element, the atom of that element will accept 2 electrons, right? And if there is 1 electron in the valence shell, then it means that atom will lose that electron, right?
Yeah.
So this is what we say, that valence shell electron gives us information about the bonding pattern. Okay.
Yeah.
About the
Yeah.
bonding pattern.
Bonding part.
Okay. For example, in carbon, there are 4 electrons. So it means it is neither it will lose electron, neither it will gain electron. It will share. Okay. It will tend to share electrons with some other species. Okay. That's
Yeah.
why carbon is covalent in nature. Just
Yeah.
I'm just telling you. We will discuss this in detail. I'm just giving you a brief idea that what information we get from the valence shell electron. Just like the sodium. In sodium, we have discussed that there is 1 electron in the valence shell. So what does this information tells us what can we do with the one electron. Like the sodium has one electron in the valence shell. So
Like
yeah, what is the bonding pattern of sodium?
yeah,
Will it lose the sodium or will it gain the will it lose the electron or will it gain the electrons?
it will lose.
Lose. So
It will
how we get this
lose
information? We get this information from the valence shell electron. Okay, on the basis of valence
because
shell
of the
electron.
valence.
Yeah,
Yeah,
on the basis of
valence shell. Yeah.
valence shell electron, we decide what that atom is going to do. Okay, particularly whether that atom will gain electron or whether it will lose electrons. Clear? Are you clear
Yeah.
with this? Okay.
Yeah.
Okay, now, yeah, this so valence shell electron gives us information about the bonding pattern. Since electrons are same, so remember this thing that sorry that electrons are same. So it means the chemical properties of all these three isotopes will be same. Okay, the chemical. You know what is the chemical property? Chemical property means how they will react. Okay, how they will make bonds. Since you know all of these have four
Mm.
electrons, all of these three isotopes have four electrons in the valence shell. So it means these all isotopes they are going to share electrons. Okay, they are going to share electrons. Let's suppose there is oxygen. Okay, there is
Shell.
oxygen in front of carbon. So what will happen? Carbon and oxygen will combine, they will form carbon dioxide. Similarly, this carbon will combine and will form carbon dioxide. Similarly, carbon 14 will combine with oxygen to
Yeah.
form carbon dioxide. So this pattern is same. This is what I am emphasizing on that the chemical properties same. Why chemical properties are same? Because electrons are same. And these electrons, since these electrons are same, these electrons in the valence shell, they tell us whether how that atom will make bond. Okay. So if all the three are following the same pattern, it means their chemical properties are same, right?
Mm.
All of these three have same number of electrons in the valence shell. It means these three isotopes they have same chemical
Same.
properties.
Yeah.
Okay, are you clear with this? Chemical properties of isotopes are same, right? Here, Rohan, can you hear me?
Now I can hear you. I write all of this down. Yeah.
Yeah, okay. Uh,
Hello.
yes.
Okay. Do I write all of this down?
No, no need. I will share this. I will share with
Okay.
this file with you. You just need to solve that
Okay.
exercise which I told you. Okay.
Yeah, yeah, I'll do
Now,
it. I'll do it before tomorrow.
okay. Now, second thing is about the physical properties. Okay, physical properties. What are physical properties? Physical properties are those which are apparent to us. Okay, just like their state, whether they are solid, whether they are liquid, or what is their boiling point. Okay, physical properties. What can you suggest about the isotopes' physical properties? What will be
Isotopes
their
physical
physical properties? Will they all have same physical properties or different?
different.
Why?
Maybe because they have different mass number.
Yes, exactly. You are right. Physical properties of isotopes are different. Okay. Why they are different? Because their masses are different. Okay. All these
Mm.
three, you see, it is carbon 12. It is lighter in weight as compared to carbon 14. Right. So they have different masses. Are different. Why they are different? Because their masses are different. Right. Then their
Yeah.
densities are also different. Right.
Yeah.
These all come under physical properties, right? And all, as well as their melting point and boiling points are different. Okay, so their physical
Yeah.
properties are always dependent on their masses. They have different masses, so that's why uh, it actually we can say it depends on the neutron number. Since neutron number is different, so their physical properties of all these three isotopes will be different. Okay. All these three isotopes will be different. The thermal properties will also be different. But when we talk about the chemical properties, their chemical properties will be same. And I have given you the reason why chemical properties are same. Because they have same number of electrons, right? Why they are same?
Electrons, yeah.
Because they have
They have the same,
same,
same amount of
yeah,
electrons.
same number of electrons, not amount. We say uh, electrons. Okay, there is a difference between
Number.
amount and
Uh,
number, right? Amount is not a fixed thing.
yeah.
Number is fixed. We can count number. Okay. So they have same number of electrons, and
Yeah,
also
same number
their,
of
yeah,
electrons.
their valence shell electrons are same, right? So this is about the isotopes. We can
Yeah.
check this from the book as well, what they have mentioned in the book. Till now, if you have any confusion, you can ask me. Okay, what are isotopes and anything which is confusing.
No, no, it's not.
Okay.